Hello friends, in this video we will talk about a very important topic of computer science, and I'm really sure that most of the people consider this a nightmare. If the topic, this dynamic programming, a problem on this is asked in in interviews, then it becomes very hectic. If it is not practiced or not heard by anyone, any student, then it very less probability that can be solved in the runtime, I mean in the interviews. So better approach is master enough number of problems, handle the dynamic programming in a very simple way during the interviews. If you set more during your practices, you will bleed less during your interviews. So let's try to decipher what is a dynamic programming and what are its conditions on which it can be applied on any problem, given problem. So we will talk in detail in this video about everything for dynamic programming. So dynamic programming. In dynamic programming, what happens? First of all, what it is a paradigm for solving some type of problems. Now what type of problems? They should have few conditions. First condition is overlapping subproblems. Means the problems, if you divide it further, then some of the subproblems should be common. And the second is optimal substructure. Most of the students find easy to understand overlapping subproblem, but find it very difficult in understanding what is optimal substructure. So in this we will decipher both these terms and try to understand what it takes to solve our dynamic programming questions. Let's go. So in overlapping subproblem, let's say you are given a problem, right? You divide it into smaller problems. It can be 2 or multiple. Let me put 3 so that it doesn't look like it's a tree that I am building, but definitely it's a tree, but not a binary tree. So let's divide this again, right? Let's say we have divided the problems into the smaller problems. It's just like recursion, right? In recursion also we divide the problem, but it is a special case of recursion where we divide the problem of the similar nature but of reduced size. Here we are dividing the problem into the smaller sub problems, and these sub problems can be a little bit different as well, right? So let's we have divided this and created a subtree. Now overlapping sub problems. Here this means, let's say if we solve this problem and the similar problem is this one. So if we solve basically this one, then this will automatically solve. We can combine, we can use this as a reference and use the results for instead of solving this again, right? This is overlapping subproblems. Mean when we divide the problems at different level, it's not that at the first level of division the problem should be common. No, it can be at further level as well. So there can be multiple level of problems. We can divide it in a hierarchy, and let's say this is at the second level. If this is first, then this is a third level, right? And this sub problem and this sub problem are same. So instead of solving 2 times, we can solve one and use the result for solving this for the second time. Okay. Now what is optimal substructure? Optimal substructure is basically, when we say optimal substructure, we are saying whatever optimal solution exists for this problem, right? Others common problem will also have the similar optimal solution. When we say optimal, optimal means fastest or lesser cost of equal solution or equal potential solution. The cost it will take, and cost can be in memory, in terms of CPU, or in terms of any other resource, right? Or even within the problem, it should not be the case that, let's say, let's take a graph problem. I'm just taking this randomly, right? So here, whatever is the cost for reaching to this point, right, the cost of this will be same, right? Let's say if you come from this side and there are few restrictions, right, and let's say this connection is available only if you come from this route, this is available, right? Then to reach this particular node, if you're coming from this route, only this path is available. But if you're coming from this route, then other path is definitely this one and this one, right? So at this point, if I say what is the optimal substructure for if you come from there, definitely this one. But if you come from this side, then the optimal substructure may change because you have one more option, right? So in this case, you don't know about the optimal substructure of that particular problem for going from this node to this node. So in this case, dynamic programming can't be used because there are a few more options are available, and those new options which are opened up can provide a better solution, right? So in this case, this DP can't be used. But if you have overlapping subproblem and optimal substructure problem, then definitely you can solve this problem using the dynamic programming, and it takes polynomial complexity, not the non-polynomial one. Or for example, if you go by brute force solving each subproblem, the basically your complexity go n to the power some n, something like this, n to power m, right? This is non-polynomial. But if you go polynomial, which is basically n to the power 3, 4, what some number, right? So then this is polynomial complexity, and this is non-polynomial, and this type of complexity are avoided. Even 3, 4 is fine given the problem is very large. Complexity of 3 and 4 may go, but it is acceptable compared to non-polynomial or exponential things. That's why we use and apply this dynamic programming to solve problems where we have overlapping subproblems and optimal substructure. Now when you solve this, what type of things will require? Definitely it's type of recursion. If you, for all the problems which are dynamic programming we can apply, then you can write two solutions. First is definitely recursion one. If you are able to write the recursion one, then using the dynamic programming, there are two methods basically, I'll talk about it, and that can be applied. But recursion is very, very important to understand for dynamic programming. If you want to know more about recursion, I have a video about the concept provided with different examples. I'll put those the links of those videos in the description of this video. Please go through that. Now let's talk about how we will solve this dynamic programming using two methods which we have. First method is memoization and second method is tabulation. Now these are the two different methods, but what they are doing, they are storing the results of these overlapping subproblems so that they can be reused when a new problem of similar type comes, right? In memoization, this is a general concept. Memoization means storing something in memory, right? Now here what we are storing? We are storing the problem and its result after solving once, right? And then we are basically reusing this solution for other subproblems. In case of tabulation, what we are doing, we are creating a table and building the solution from bottom to top, means solving the smallest subproblem, and then we will move forward and use those stored values for solving the bigger problem. So in that way we are building the solution from bottom to top, whereas In memoization, general approach is to divide from top to bottom, basically divide the sub problems and solve once if and store the results, so that whenever in the next time when we see similar type of problem, we will further without further solving it, we will use this memoization technique to take the results and use. So these are the two basic methods, and if you understand till here, if you see the examples, you will understand how easy the dynamic programming can be, given that you master the recursion. And for any dynamic programming, if you write your recursive solution and then use this memoization or tabulation, both technique can be used. And as I said, memoization is top down, from top to bottom, and from tabulation is from bottom to top. We are building the solution. Now in some problems, tabulation is very easy to think of, and some memoization, but given you are able to write a recursive approach for dynamic programming, then memoization will be a cakewalk, and you will be applying this on almost all the question that you solve. Though some problems can be very easy to think of using tabulation. So we will see the examples in other videos, or very deeper examples, but in this video, let's see a small example of Fibonacci series. So let's see the Fibonacci series. What is Fibonacci of n? It will be Fibonacci of n minus 1 plus Fibonacci of n minus 2, right? Of nth Fibonacci number will be sum of the last two numbers, right? Now this is, you can understand, this is a recursive approach, right? You are able to write Fibonacci series solution in a recursive approach, and the base condition for recursion is n equal to 0, right? It will return 0. It will return 1, right? So now how the series will look like: 0, 1, 2, 3, 5, 8, right? And then 13 and so on. Means each number is a sum of last two numbers. Each number is a sum of last two numbers. Each number is a sum of last two numbers. Okay. So this is how we have written Fibonacci series. But let's say now this n is in billions. How will you solve the problems? And you are given a lot of numbers in a series, in a stream basically. Now you have to find the recursion, basically the Fibonacci number of that nth number. That will be time consuming, right? So what if you solve this and store the result somewhere, right? So let's say you are given a problem. If you store this result in, and which is called memoization. So here let's use this memoization technique first, which is basically top to bottom, right? You are solving the top problem and then going bottom. So let's say now you have to find this thing, Fibonacci of n equal to n minus 1 and n minus 2. Then you will keep going. When you solving n minus 1 and n minus 2, because this will, in the next iteration, to find the solution of this, what will happen? Fibonacci of n minus 2 and plus n minus 3, right? And this will be Fibonacci of n minus 3 plus Fibonacci of n minus 4. So you see, this subproblem and this subproblem is same. So if you solve once, you can solve, you can use the results for second time. Similarly this one, right? So using the memoization technique, you will keep on going till you find the result. Whenever you find the result, you will store in a hash map or any other data structure. I am taking just a hash map, where you will store, your key will be n, basically whatever the number, and then value will be value, whatever the result. So when you are running through this recursion, if you find in this table, in this map, if n minus 2 is already existing, if it is existing, just use the value and return instead of solving further. But if it is not, then continue the recursion till the bottom and save all the results from bottom to top in this. So this way the program become very easy. Let's write the code. So dp of fib of n, here we check if n equal to 0, return 1, else what you have to do, first check if, and consider this is a map and we are taking as a global variable, okay, so, or a new map, let's use this way. I'm using, by the way, Python syntax, but you can use any other. So if map dot has n, right, then return map value from map, else we have to return dp of fib n minus 1 plus dp of fib n minus 2. That's it. We have used a technique called memoization, where we are using a data structure for storing the results of the previously solved problems. Here in this case we have used a map, and just we have used the recursion solution. Before solving the recursion, we have checked in that data structure if value exists, then don't go further solving that problem, reuse the solution. And in this way you have solved a DP problem using recursion and memoization technique. And if I say now, with this technique you have mastered almost more than half of the problems in DP. Any problem that comes, just master the recursion part of it and then use the same technique. It will solve the problem without any doubt. Let's solve the same problem using tabulation method. So let's solve this Fibonacci using tabulation method. In tabulation, what is tabulation basically? It is solving the problem from bottom to top, right? In bottom to top means you are building up the solution. So to solve Fibonacci of n, you know you have to first find n minus 1 and n minus 2. And this is a linear thing, right? From number will grow from 0 to n, whatever the n could be. So in this case, you will again store the results and build up the solution. It's a linear one, so we can take 1D array at max of what? N size, because n is the last number that we have to calculate. Now from 0 to 1, 0 is added here, right, and then 1, and then just continue. So continue means iterative approach. For loop I equal to 0 to n, or let's say here in this case 0 and 1, 2. So what will be the case? Fib of I equal to fib of I minus 1 plus fib of I minus 2. I is starting from 2, and in the end you will fill this solution, right, using iteration. This is a dynamic programming solution using the tabulation technique, building the solution from bottom to top. But again, here in this case also you have to master this recursion. Once you master this recursion of any dynamic programming, then you can think which approach is easier for you, either memoization or tabulation. One of them will solve your problems. Here in this case, because it's a 1D, only number will move, so it's basically 1D array, but at times you may require 1D, 2D array or even 3D array, multiple dimension array. But the final, basically the crux of the tabulation is you build the solution from bottom to top. Find the smallest problem, solve that, and add up those things to solve bigger problems till you reach your given problem. So I hope you got the concept of dynamic programming. If you like this video, please share with your friends and other colleagues and students. Please like this video, click on the like button and bell icon so that you will get to know more videos on this. I will create more examples and solving using the DP problems. If you like this video, then it will definitely help this video to go to further other students. Subscribe to this channel. This will help me and motivate me to create more videos on such topics. And please feel free to let me know in the comment section what you are liking and what you are not liking. If you have any suggestions to help me in creating the content, whatever topics that you want me to create content on, I will be more than happy to create content on those particular topics. Please subscribe. With this note, this is BK from Anika signing off.